Hello everyone. So this is the first one. We will talk about a very basic fit here. So let's go through the structure first, then I will go to the each step in detail. You can see first one we declare some formula that we will try to use this formula to model our data. So this formula would use a TF1 function. This is a 1D, let's just mean one variable function, okay? So then we create some data. In this case, because I don't have data, so I make some data. In your case, probably you already get some data from other like source like experiments or whatever your analysis. So in this case, just make some data. Then we have data, we have formula, then we just do the fit here. So we set the initial condition that's very important for the fitting part. Then just code the fit. In this case, we store data in a t-graph object. So to code a t-graph fit function, then it will do the fit for us. Then we get the fit result. Like in this case, we do some formula here. We have some parameters, just two parameters, C1 and M. And we'll try to see what's this. Okay, so this is a kind of overview of this script. Then we go a little bit deeper for the syntax part. Okay, so in order to use like a t-graph fit function or th1f fit function, you need to have the formula that's in tf1 or some I think it's tf1 here. Okay, so tf1 object is for 1D function. So first you have kind of the name for this object here. You can set whatever. Then you define a function here, and this is the constructor I like most because that you just define this my function by a function here, and then you can do the fits here. And then you specify the range from the minimum to maximum and how many parameters in your function. In this case, in the my function, I have two parameters here. 0 is for constant 10 here, C1, and second parameter PAR index 1 is for the slope or some integer, so some value for sine, in a sine how many period within 1 pi here. Okay, so this just two parameters, so we have two parameters, so we set 2 here. We will talk about other constructor for the tf1 function in the second tutorial. So this but I will show you, this is one I love most here. Okay, so in many cases the fit range in your definition in the function constructor here may not so important because the fit will use the container like t-graph objects range fit. But when you want to plot the function, it's important to specify the range here. Just a note here. So you can set the name for the parameters. Like I say, I call the first one as C1 and the second one as M here instead of PAR 0, PAR 1 here. So let's take a look at the function itself. The function, my function here it has some fixed structure here. You always return double, and you take a pointer as the coordinate and a pointer as parameters. Okay, so sometimes I would just for easier to read, I would transform to something more meaningful, like the first parameter will be degree, and the first parameter will be constant, the second parameter will be kind of integer here, sorry, a number here. I always make mistake here. Okay, then you got return from here. Alright, okay, so that's it. That's very simple way to make a TF1 object here from this constructor. Okay, so we have function, then we have, of course, we need to have some data to let this function to fit. So in this case, I consider to use a tgraph object to kind of store my data. So I use the function I wrote, generate data, just a dummy one, just you know, just make this, just to make this a tgraph object here. So you actually basically you generate some x and some y with your data point here, and then you assign this, you put into the constructor to graph here. This is not an important part, so I would like to skip this one. So if you want to see, just here. Okay, so the thing is that I use some number for the parameters. Then I would try to see whether the fitting can show me the similar parameters or not, because I also added some random number as noise, so it should be close but not exactly the same. So if I do my job right, actually I already tested, it should be very close to this number here, this kind of answer sheet here. So the thing is this, you can use TF1 has evaluate EVAL function. You input one value here because it's just a one-dimensional one, so you get a y here. Okay, this is the generate data function part here, not very interesting here. So alright, very easy. So we have data, we have function, now we do the fit. Before fitting, it's very important to set initial value. So we have two initial value to set because we have two parameters. You can either set parameters, then you set the first one, second one here, or you can use something like F1, then set parameter. This is exactly the same, but just no S. Okay, so this one would be, okay, I will set zero, the first one to be 0, and the second one to the first one is index. Okay, the second one to be 1. Okay, this line work as this, the same as this two line here. Okay, so very easy. So we just code the fit, then put the F1. This is our fit function here. We declare here. Okay, then we put some option here. Normally I like Q. This means quiet, and means not draw, because then you will draw some data. We would draw the graph with the fitted line here. Also, you tried R. Sometimes R is useful because the R means use the fit range, not in your data container, but in your function range here, S minimum to S maximum here. And M is more for improved improved algorithm here. So in this case, I just use the default option, so I put it here. And then there are also draw option later, but you don't need to specify that. You can still work. Okay, so very good. You got the fit, and also when you do the fit, you will update your parameters. So to get the first parameter, you use a get parameter 0. This will be internal the first one and also the second one, just one here. Also, you can call the get chi-square. You can get the chi-square. The NDF means the number degree of freedom. Normally is the data point minus your parameters. Okay, so let's try to take a look. So 0, 1 here. Alright, this fits very well. You see this is a graph here, the data here, and this is the red curve is fitted line here. So this part is the message happen during this line here. So actually basically it's similar to you don't need to print by yourself. You can print you can view a summary. So if you use a Q here, you just don't print anything. You can see they're just very quiet here. Okay, so let's see. We get 1.49 something and 0.7 is like close to our answer. Let's check a look. I think it's yes, right? Very close. So this is a very easy and basic way to do the fitting, and I hope you can enjoy it. See you next time.